What's the difference between a rational and an irrational number? And what's the difference between a rational and irrational number? Okay, so I'm giving you a number and tell me whether it's a rational or an irrational number. 1 dot 3 4 3 4 3 4 dot 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 dot. This type of number is it? Okay. Can you arrange that in the form of a fraction? Okay. Yeah, you can. It's a rational number, correct? Because you can take, like in your algebra, x equal to 1 dot 3 4 bar, and then multiply with 100 on both the side. You will get 134 dot 34, and then try to subtract. You will get 99x is equal to 133. So you can see we have arranged that in the form of a fraction 133 over 99. Okay, can you see it on the whiteboard? Can you see all this working on the whiteboard? Alright. Have you understood? If not, you can ask me again. Okay, we have done all the properties. Now we are going to go on the closure, commutative and associative properties of the real number system. So I told you what is a real number system and what is an imaginary. Yeah, one thing is left as imaginary. Now imaginary is totally, I told you they are like aliens in math. Okay, you can compare them as an aliens which you haven't seen. What is that? When the mathematicians were solving the questions, they got something called square root of negative 1, right? And if I say square root of 4, what will be your answer? No, plus minus 2. Now you are a grown up kid and you should say plus minus 2, okay? Now, but if you do the reverse of plus 2, if you do the square of plus 2, you will get 4. If you do the square of negative 2, you will get 4, right? In the both way, this answer is correct. Alright, but if you do a square root of a negative 1, you are unable to get, because if you get 1, okay, just take a square root of a negative 4. Alright, and if you take plus minus 2 over here in this case, then come on, square plus 2. I told you square of a plus 2 will give you positive 4, and even the negative of this, it will give you a positive 4, but you are not getting negative 4 in any of the cases, and they were unable to solve this, so they took this background into the imaginary number system. Means they named this as alien in this real number system life. Okay, and said, so they denoted this system as I. Whenever they said you will get a negative 1 under the root during solving the question, you will name it as I. So like negative root 4. So just put that negative over there and you will get 2I. Alright, now understand how this 2I came. Negative times 1 into 4. Alright, just break it like this. Just break the negative 4 like this. And then square root of 4 is 2. Often written root negative 1. Root negative 1, as I told you, just denote that by I, you will get 2I. Okay. So this we will go into detail when we will go in the complex number system, okay? But just now we have to do the numerical operations. Okay, so a numerical operations assigns a real number to every pair of real numbers. So there basically I told you 5 basic properties. Can you tell me the 5 basic properties? of the real numbers. Can you tell me yeah, properties of the real number system? The right, right, right. Identity and zero, they both are same. All right. Yeah. So these all properties you must have done in algebra also. You must have had done in algebra. So a closure property, first of all. A closure property says whatever you do, now I'm telling you in a rough idea, then we will come into the maths. Whatever you do in a daily life, whatever activities you do, if you are a man, if you are a human being, then you don't change into the animals until and unless you do things that are realistic with humans. Means they are justice with humans, right? If you do things wrong with the humans, then you will people say that you are turning into an animal. So that's not the closure property. That is a disclosure property because you are changing your identity, right? If you do things very clearly, humans will call with your name. If you do your activities in a paranormal way, so people will call you something else. If you do things very wild, people will call you like an animal. So if your identity changes because you were born as a human being, but if your identity changes into an animal or something like that, then you are said you are disclosure. So in the same way, if you are using integers, come on, randomly choose two integers. Yeah. Okay. Then multiply these two integers. What are you getting? Eh? Okay. And try to add them. Okay. What are these numbers? Okay. If you're taking an integer and if you're getting the result as an integer, then this property says that this is a closure properties and the result is closed, means preserved. Okay, if you are taking a fractional part 2 of 3 and the other fractional part as 5 over 6 and try to multiply them or try to add them, you will get the try to multiply them, you will get 10 over 18. Okay, so this is what, this is also a fraction. Try to simplify it, you will get 5 over and 9, right, in the simplified format. This is also a fraction. So this is also what, a closure property. Are you getting it? All right. Now the next is the commutative property. This is you will tell. Randomly choose two numbers and try to explain. Meena. Yeah. Correct. Whether you do it from the left side, whether you do it multiplied from the right side, if you get the result as the same, then this is the commutative property. Now remember, these properties will work in addition also in multiplication. So you have to justify them with multiplication and addition both. So you will say commutative in multiplication, and if you, because if you are doing multiplication, if you are doing addition, you have to specify that and write that it's commutative under addition. Okay, because in geometry you have to signify your sentences, means you have to give detailed analysis of your sentences, right? Because the examiner would be knowing that, but he wants that you should know the name of the properties. That's why he wants the sentences. Okay, so this is called commutative property of multiplication. And in the same way, if you try to add this up, so this is my word, right? If you try to add this up in this way, you will say this is commutative property of addition. All right. Now the next is associative property. Come on, give me an example. Quick example. Okay, so never mind. Write it on. Write it. Correct. Yeah, this is the, you can say, the associative property. Whether you associate that two first or you associate the last two first, the result will be the same. So this is called an associative property. The next is the identity, and this property has two identity operators. So under addition, what is an identity under addition? I'm asking the identity. You are telling me the inverse. Okay. Yes. Just see things that you know things very clearly, but the problem is you are visualizing something different. So identity. Identity means, remember one thing, identity means whatever you multiply with a number or whatever happens with you in whatever situation you go. Just take it as like this, in whatever situation you, whether it be a hard situation, whether it be a tough situation, or whether it be a easy situation, you remain constant, means you don't change yourself, right? It means whether when you are harassed by someone or whether you are in very difficult situation, you don't get high temper. It means you remain calm. So that is called identity. So what is that element when you add up and that doesn't changes the number? Correct. So 0 is the identity element under addition. Okay, so 3 plus 0 is 3. So 0 is the element, identity element, and 3 is the number whose identity remained constant. Before it was 3 and after also it's 3. Now what is that identity element under multiplication? Correct. 3 times 1 is also 3. So 1 is an identity element under multiplication. Can you hear me clearly? Okay. Now the next is inverse that you were telling me. Come on. Now you can tell me. Correct. Right. So that's, now you can see under multiplication you are getting the identity operator as a result. So remember you have to get this operator as a result and you will do these operations. Okay? You're correct. Now the distributive property, as you must be knowing very well, if it is written a times b plus c. So this says you will give things, if your mother gets two chocolates, right? So what's the case? Whether it will give you first or your sister first? You. Okay. Whether it will give you two chocolates and her zero, or whether it will give you one to you and one to your sister. That is called the distributive property. Means you have to make things balanced, right? You have to make things balanced. In the same way, this is your mother, and this is you, and this is your sister. And your mother is giving a chocolate to you also and to your sister also. It means she is loving you equally with you, and she is doing the justice with your sister. All right. So you can say. So your mother is with you also and with your sister also. This is called the distributive property. Means you are distributing the things, the love, and each and everything proportionately in the balanced way. So if it is like this, a plus b times c plus d, what will be the result? Right. So this is your mother and father both together, right? In the same way. So you can, what you can do is, yeah, you are absolutely correct. They both got to do chocolates for you. So now you can write A times C plus D plus B times C plus D. This is the way in the steps you will break it out. Okay? Then AC plus AD, then BC plus BD. This is called the exact way, exact stepwise distributive properties. Okay, I know you must be knowing all these things, but I'm trying to revise all these things so that you, whenever you do the questions like this, and you can write it on the right hand side. I'm showing you an example this way. That's why I'm revising with you all these things. Can you see this? Right. You will do the questions, and on the right hand side you have to write, like this is the associative property of multiplication, then you're using commutative property under addition, and then you are using this, right? So these are the steps. When you will solve the question, you have to write it on the right hand side. What are you doing? I know when I would be checking, or someone else would be checking, he must be knowing very well what is that, but he wants you to write it down. So quickly get a pen tab before that we start all these things. Okay. Yeah, because you need to write all many of the things. Okay, okay. I'm giving an example, and replace each question marks with a number that makes a statement true. Okay, now this is just a practice question I'm giving you, and these are very easy question, and I will time you for this. I'm giving you only 2.5 minutes. Okay, just hold on, wait. Before time, let me make it visible. Okay. Uh, One thing. What you can do is, do you know how to type over here? Okay, this is the option called A. You have to just pick up that option, then you can type your answer quickly instead of writing with the mouse, because that will take a lot of time and that is quite difficult for me also to write with the mouse. Okay, so just do it quickly. Just you can write in the short form. If it is commutative, you can write commutative. If it's distributive, just write this over here. Okay, the properties and all that. The time starts now, and I'm giving you 2.5 seconds for this. 2.5 minutes, sorry. What happened? Okay, that's a logical question. You can directly see it from. Okay, have you done the last one or should I tell you? Okay, right. Because b is 0, so you will get a plus b is equal to a. Right. Okay, you can see the questions which I haven't taken up, right? And I'm going to mark up. They're a little bit, you can say, this is not a distributive property. This is not an identity. Again, whatever, just like this, you have done with this. Okay. Yeah. This in the second step you say wrote it right, but in the yeah, this is also an inverse, and this is you can say commutative, right? Because it's not an associative because you or you can you can't say this is distributive because you haven't distributed the product. This is distributed because you are distributing the product. But you can see you are changing the position. 10 was on the right hand side and now the 10 is on the left hand side, and this is what is the property of commutative, right? Now if they distribute this 12 inside this to both the numbers, then that will become the distributive property. Now this one, 17. So question number 17. For what value of x does 3x minus 1 has no multiplicative inverse? So let's go on the different whiteboard. 3x minus 1. Okay, what is the multiplicative inverse? If it is written 9 and if you multiply it by 1 over 9, you will get the result 1. Okay, you should get a result 1. For what value? Okay, now let's take x equal to 1. What are you getting this? Okay, you said now take x equal to 1 the value. So you will get yeah 2. So the multiplication of multiplicative inverse of 2 is 1 over 2. So this is possible. But now try to take x as equal to 2. Then you will get 3 times 2 6, 6 minus 1 5. Again 1 over 5 is the multiplicative inverse of 5. So this is also possible. So they are saying they want that particular number in the previous whiteboard you will see they which should not have its multiplicative inverse of this quantity. So just look at over here. If I take x as equal to 1 over 3, what will be the result? Okay, so right, right. 0 times 1 over 0. 0 yeah, so yeah. So 0 times 1 over 0, right? What will be the result? Right, it's undetermined, you can say, infinite, whatever you can say. It's undetermined. 0 over 0, infinity over infinity, infinity times infinity. These are three things which are undetermined. Okay, and 0 over some variable, some variable over 0 means a over 0. This is said to be as infinity. Okay, these are the few terms that you should remember. Now it will have a lot of use over here. Okay, now all these things done. Then we are going to do now the collinear points. Now we are going more deeper in geometry, and the next is collinear points. Collinear, as the name suggests, in a line. So if 3 points are given in a space, so whether you can determine these are collinear or not. What are the three basic properties by which you can determine these are collinears or not? Don't go that deeper, right? That's slow. Yeah, I'm asking you. I'm asking you. Yeah, simple, right? Right. That is more far away, right? We will go in that. I know you may have done all these things in algebra and all that stuff before also. So, see this. there are 3 points given. First of all, it must make up a set. Okay, so if you join this like this, now you can see this is making up a set. Set is what? A combined set of objects. Alright, so that is a set. Now second thing, it should lie in a straight line. So this is not lying in a straight line, so it's not a collinear point. While if the 3 points are lying in a straight point, then it's what? Well, it's a collinear equation, collinear points you can say. Okay, it says that it states the set to which the defined term belongs. A non-collinear set of points is a set of 3 points or more that do not lie on a same straight line. Now I'm taking 4 points. 1, 2. Okay, let's draw it clearly. This one is A, this one is B, this one is C, and this one is D. Now tell me, are all the points collinear? Right. Even if the points are parallel, that doesn't mean that they are collinear. It means they are only parallel. Okay. Now the distance between the 2 points. How to calculate the distance between the 2 points when they are arranged on a number line. So if you have a number line like this, is it visible? So I'm saying try to find the length of AG. Can you find the length? AG, sorry. AG. Can you find? Hello? Okay. The process says, right, correct, 6. The process says you can find the distance very easily. The only thing you have to remember, distance is always in positive numbers. Okay, you can't write the distance in negative number. So you will do it like this. You will place the things in the mod, even if you get the negative quantity, and then you will write it like this. So if someone says to find the AG means G minus A. Okay, and if someone says to find GA, then it means A minus G. Means whatever the point on A, the GA will be -1 minus -5. And but keep all the things in mod. Right? This is an absolute operator, and you can say it mod also. But remember, it's an absolute operator. The two parallel lines denoted, that means an absolute. Over here also you will get 6, and over here also you will get 6 in both the cases. So this is the way the distance between the 2 points on the real number line is the absolute value of the difference of the coordinates of 2 points. Now you were saying order of points on a line. Now there are 3 points collinear, that is A, B and C. These three. I'm taking a lot of parallel lines to make my work easy. Okay, now tell me in a different way. This is A, this is B, this is C. So the order says B is in between A and C. Whether to check whether it is a center point or not. How can you check whether it is a center point or not? Correct. So if the two coordinates are given, x comma y, and this one has x1 comma y1, So how will you find the coordinates of B if it is a center point? Very easily, just add up the x coordinates, x plus x1, and divide them by 2, and y plus y1 divided by 2. Have you done all these things before or not? Okay, this is the midpoint formula. You can say midpoint theorem. Okay, never mind. Just hold on for a second. Let me check one thing. हर क्लास में हाँ ठीक है okay, so this was the midpoint. Now the line seg just hold on क्या हुआ ठीक है alright, now we there are something called congruent segments. Congruent, as the name suggests, congruency means equal, exactly mapping and equal. Congruency and similarity, these are the two different things, right? If someone says you and your sister are similar to each other, that doesn't mean they are congruent, because similarity doesn't says that your height and your sister's height would be equal, right? Similarity says that your features would be equal, some of the behavior would be equal, so that is called similarity. And if someone says that you and your friend are exactly congruent means you are getting the equal percentage, you are getting the equal marks, your height would be equal, um, means everything will be equal, so that is called congruent, right? So there's are two different things between congruency and similarity. So congruent segments are the segments that have the same measures. When you are talking about the congruency, you will go into the measures, but when you are talking about the similarity, you will go into the ratios. Okay, so we have to deal in congruency now, so we have to main focus in congruency, then after that we have to deal into similarity, but I told you just now what is similarity. Now the next thing is the midpoint of the line segment. As I told you, the midpoint of the line segment is the point of that line segment that divides the line segment into two congruent segments. Means if I draw a line and if it is a midpoint, then it will divide the two line segments into exactly equal. Means they will make the two segments congruent, this and this both. If it is A, B, C, B is the exact midpoint, then AB will be equal to BC. So this is called, and for this you can draw a bisector of a line, and a bisector of a line is this. Okay, this. You can see this. This is the bisector of the line, and by the compass, okay, by the compass, if you want to draw a bisector of a line, then how can you draw? I don't have a compass over here, but I would be trying to explain you. Okay, if you have used the compass, then first of all you have to use a scale. Okay, do you have any idea how will you draw a bisector of a line segment using a compass? Okay, okay. In a compass you can see there are two legs, right? And one is having a sharp point edge, and other one has a pencil. Let me draw. Okay, that blue one denotes the pencil. Okay, you have to take this end point. I'm drawing this end point with the light blue color, this blue one, and keep it over here. and then you have to stretch the compass more than the half, and you can roughly make an idea that this may be half, so you can arrange till over here. Okay, you can arrange the compass till over here, and you can make it like this, if you can see this and this, right? Stretch it more than half, and then okay, now with this pencil, right, you will make an arc like this. You will make an arc on the upper edge when you will roll the compass, and this point should be fixed, means this is stuck over here, and then you can make an arc like this and make an arc like this. Okay, means you are holding the compass and you are making the arc. Now let's remove the compass and let's see where is the arc. Okay, now this, you made this arc and this arc. Now do with the same over here also on this another red point. Just drop another fixed compass, and then you will make an arc like this. 1, 2. When you will see the arc, you are getting a two end points, this one and this point, and join these 2 points. Try to join these 2 points, and you will get the center of the line. Okay, have you understood? Any rough idea? Or if you haven't understood, I will make it more clear. Okay, you got it. You have to just roll the compass in both the arcs, on both the direction, and you have to stretch it more than a half, and then you will get two arcs, and wherever the two arcs are intersecting, you have to take those 2 points and you have to join those 2 points. Then you will get the center of that. Now this red line is called the bisector, and this point is said to be as midpoint. Okay, and I told you how to find the midpoint. If the 2 points are given like 2 comma 3, and this is given as 5 comma 6, so can you tell me what would be the midpoint? Yeah, no, just leave it in fractions. Correct, absolutely correct. Right. So this is the way to find out the midpoints and all that. Okay, and okay. From next we will start up with the angles, and then we will from angles we will go into the congruency and more angle definitions, bisector of the angles, adding subtracting angles in our next class, and then we'll move on to triangles. Okay, so today we have completed almost one unit. Okay, and I will give you your homework on your email ID. Okay, whatever would be the homework and everything, or whatever the stuff, whatever the ways, that will be sent on your email. Okay, so I'm going to wind up your session now. So bye bye and have a great day.